our discussion of air masses, mid-latitude cyclones, and weather. In this installment, I'll be going over wind, focusing on pressure gradients, wind direction, and wind speed. If we move to our contoured pressure measurements on this particular diagram, we find blue lines are contour lines that are showing us pressure changes across the U.S. and parts of Canada in 4 millibar increments or 4 millibar changes. So that is the contour interval at which the pressures contour lines were drawn. And we'll notice that there's closely spaced contours and widely spaced contours, and there's a range of pressure shown here. On the right-hand side, there's a bullseye. I'm just highlighting 996 as a relatively low pressure in this diagram. And if I come up towards the top left, we see 1036 as a relatively high pressure. And these are in bullseyes. So we can place an H here on the top left and an L here on the bottom right. These correspond to our cyclone and anticyclone. Here's our cyclone in this diagram. And airflow in this area would be up as well as horizontal. And then under the H here, I'm going to write anticyclone. Okay. And airflow is going to be down in this area. Now, anywhere I want to put a dot in here, I could ask the basic question, what direction is wind going to blow? And it's going to blow, or it's going to move as a function of the pressure gradient force. Okay. Pressure gradient force says that, or basically tells us that wind is going to move from high pressures to low pressures, as I'm drawing here on the left-hand side. And we get down from, let's say, 1022, which is where I drew this dot, 1022. We're down into a little trough here at, let's say, 1019, something like that. 1016 is over on the right-hand side, so it might actually be, 1019, 1018, something along those lines. Not quite down to the next contour line. The line is drawn. In this case, I drew it perpendicular or at a right angle to the contour lines, and that's correct. However, this does not take into account the Coriolis effect and the direction that wind will actually blow. So let's take a look at some of the other dots labeled on this diagram at different locations, A, B, C, D, and E, and let's just take a look at how we might draw the wind direction there. So in this case, for A, the vector will be drawn perpendicular to the contour lines. That means it's moving from the high pressure zone away from the high pressure zone, because wind is always moving from high to low. The wind in this direction will be a northeasterly wind moving off of the high pressure zone. If we're at B, the wind, again, perpendicular to the contour lines moving from high to low, it becomes a northwesterly wind, always naming the wind from the direction or that is blowing from, right? So if you face the wind and note the cardinal direction, that will be the name that will give the wind: northeast, northwest, westerly, and so on. Jumping down to C, on the bottom of our diagram, I can draw a line from the outside of this bullseye towards the inside of it, and this would be a southwesterly wind. Okay. And then E is drawn for us, and then D, from high to low, is a northeasterly wind. Now, the thing that's not factored into this situation is, well, there's two things to think about here. One is the true direction that wind will be moving close to the Earth's surface, and this has to do with the fact that I've drawn these arrows without considering the effects of the Coriolis effect. The result here is going to be to create a kind of cyclonic flow, which corresponds to our cyclone and our anticyclone, as winds will corkscrew in a vertical fashion, which I can't show very easily on this diagram, but I'll show you how this works in just a second. The other thing that we want to think about is the spacing of the contour lines. Take a moment, think about where the contour lines are the closest. The closest lines equal the steepest gradient. There is no difference between this and reading a topographic map. And so that means that on the right-hand side here near E, if I draw a little bar here, these lines are close, the gradient is steep, and flow or wind will be strong. Come down to the left-hand side of this diagram, and I'm going to draw a wide bar here, wide spacing, gentle gradient, and weak winds. Okay. All right, so let's just adjust these for the Coriolis effect now. If we back up, I'm going to maybe come in and erase some of these guys here, 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 here. Okay. In the northern hemisphere, everything is twisted to the right. So if I redraw D, I would redraw it kind of in this direction. If I redraw C, I'll twist it to the right or direct it to the right in this direction. If I redraw E, it's going to get a little bit messy, but I can go ahead and I'll erase some of my previous notes. E would come in something like this. And what does this do? Well, it creates a kind of vortex, flow, which is going to be counterclockwise. Okay? Right? All the winds are deflected to the right, and you would think that the flow would be clockwise, but it turns out the flow is counterclockwise. Now, on the left-hand side here, where we go to the high pressure zone, I'm going to twist A in this direction, and B, sorry, A went, I just went the wrong way. Let me adjust this. A is going to twist in this direction. B is going to twist like this. Both of them are turned to the right of their the intended pressure gradient force in the system. And so what this ends up doing is providing flow which is actually clockwise around the high pressure system. All right, so that wraps up my discussion of wind direction, flow, cyclones, anticyclones, and wind gradient and velocity. And we'll move on to talk about plotting weather data and plotting fronts.